Hi, welcome to Operations Analytics. I am Dr. James Rowe from Roller College of Business at Rowan University. The topic of this lecture is linear programming applications. Linear programming is, again, one of most popular management science methods, which is being used in the industry today. In this lecture, we will learn how these linear programs are being applied to real life and real business. Look at the structure of this course. This lecture delves into linear programming applications. We looked at how to use linear programming in the previous lecture, linear programming, the concept and assumptions, and how to solve them, applications and sensitivity analysis. The purpose of this lecture is to go one step further and show you how a large number of real-life problems can be modeled using linear programming. We do this by presenting examples of models in the areas. Among many, I would like to choose 3 examples and solve them for you together. I will first explain the problem, then set up the applications in mathematical format, and then solve the linear programming using Excel solver. The learning objectives are: first, understand a problem carefully; second, formulate the linear programming objective and constraints algebraically; and the third, solve the linear program using Excel solver; 4, interpret the LP result. I would like to talk about 3 examples. The first one is financial applications, second, production scheduling, third, employee scheduling. Let us first talk about linear programming in financial sector. A problem frequently encountered by managers of banks and mutual funds and investment services and insurance companies is the selection of a specific investment from among a wide variety of alternatives. The manager's overall objective is usually to maximize expected return on investment given a set of legal, policy, or risk restraints. In this example, we want to talk about how managers can utilize linear programming to find the best portfolio given the constraints that they are surrounded with. The case in point is International City Trust, ICT. For example, the International City Trust invests in short-term trade credits, corporate bonds, gold stocks, and construction loans. To encourage a diversified portfolio, the board of directors has placed limits on the amount that can be committed to any one type of investment, as we can all understand. ICT has $5 million of available fund for immediate investment and wishes to do 2 things: maximize the return on the investment made over the next 6 months, and second, satisfy the diversification requirements as set by the board of directors. After research, the bank narrowed it down to 4 investment categories. Here you can see in this table: trade credit, corporate bonds, gold stocks, and construction loans. And they found the corresponding interest rates such as 7% to 15%. As you can see, gold stocks has the highest return rate, 19%. However, we also see that there's a cap, maximum investment cap, and in $1 million. And their limit is trade credit is $1 million, corporate bond $2.5 million, gold stock $1.5 million, construction loans $1.8 million. The board needs to make a decision how to set the best portfolio given this interest rate and also the investment cap. And they also have 2 additional constraints. The first is at least 55% must be invested in gold stocks and construction loans for some reason. And the second one is no less than 15% of their fund be invested in trade credits. So at least 15% has to be invested in trade credit. So given this objective and constraints, what is the best portfolio that we can choose, right? That is the question. If we are not constrained by these things, then I guess the best investment will be just gold stock, because it gives you the highest interest return. But you do not want to put all the eggs in one basket. So we have to choose a portfolio, and what would that be, right? That's the question that we have to choose here. In formulating this as a linear programming problem, the objective must be defined first. There are four investment options that we have in this case. In real life, you could have more than four, but let's assume that there are only four investment category. Let X1 be the dollars invested in trade credit, X2 be dollars invested in corporate bonds, X3 for money invested in gold stocks, and X4 money invested in construction loans. So there are four variables, as we can see here. And we need to formulate objectives. And from the table that we saw before, we know that X1 trade credit has expected return of 7%, and X2 corporate bonds 11%, and gold stocks 19%, and construction loans 15%. Therefore, our expected return is that we want to maximize investment return, and that is defined as 0.07 times X1 plus 0.11 times X2 plus 0.19 times X3 plus 0.15 times X4. Now we need to formulate the constraints. As we learned before, there's a cap. So let's start with caps. X1, the amount invested in trade credit cannot go over $1 million. So it has to be less than or equal to 1 million. Similarly, X2, 2.5 million, X3, 1.5 million, X4, 1.8 millions. So that's from these maximum investment constraints. And we also learned that we have two additional constraints, that they are at least 55% must be invested in gold stocks and construction loans. And this has to be formulated carefully. So the investment in X3 and X4 must be at least 55%. So 55% of the total investment, right? And total investment can be defined as X1 plus X2 plus X3 plus X4, right? That's our total investment. So X3 plus X4 has to be greater than or equal to 55% of total investment. So that's X3 plus X4 says to us. And now sixth constraint is right here, no less than 15% be invested in trade credit, right? So X1, the trade credit, has to be at least 15% of the total investment. So student can just drop this X1 to X4, this summation part, and get a wrong answer later. So make sure that X1 is greater than or equal to 15% of total investment. Therefore, we have to have this parenthesis and X1 plus X2 plus X3 plus X4. And we know that the total investment they have is $5 million. So their total investment can be maximum $5 million, but it can be less than that. And last of all, this one, X1 to X4, has to be greater than or equal to 0, because in reality, we don't have negative number, right? We don't have negative money. So this non-negativity constraint has to be added. So you formulate this, and then now you are ready to tackle the question. So if you are in this point, then what you can do is now we can open Excel and enter this data together. So let's do that.